Alright, this is your lesson on real-world rational equation problems found in Glencoe 9-6. Now, before we can get into some real-world problems, we probably need to first stop at just regular rational equations. So here's my problem. 9 over 28 plus 3 over z plus 2 equals 3/4. I'm actually going to take this problem and approach it a little differently than your textbooks by subtracting 9/28 onto the other side of my equation, okay? Isolating my constants, essentially. So then I have 3 over z plus 2 is equal to, so I need a common denominator between 3/4 and 9/28, okay? Common denominator actually would be 28. Let's see, 4 times what gets me 28? Well, that would be 4 times 7. So I'm going to multiply both top and bottom by 7. Getting me 21 over 28. Okay. And then we're going to subtract 9 over 28. So 21 minus 9 is going to get me 12 over 28. Then we're turning into a proportion, so we can just cross multiply. The key word here being proportion. So on the right-hand side, we end up with 12 times the quantity of z plus 2, which simplifies to 12z plus 24. And on the left-hand side, we have 3 multiplied by 28. Just to prove a point here that we do not need calculators in this classroom. 8 times 3, that's me 24. Carry the 2. 2 times 3 is 6. 6 plus 2 is 8. 84. Now I'm going to subtract 24 from both sides of my equation, leaving me here now with 60 is equal to 12z. Zoom out. And lastly, 12z is equal to 60. We must divide by 12. 60 divided by 12 is equal to 5. So z is 5. So this was a different approach from your textbook. Either are perfectly acceptable. In fact, there are even more ways than the two that have been presented. Alright, we're taking a look now at example 2. Anytime I see things that are squared, something in my gut just tells me, play around with it, Miss Rudolph. See if you can factor it. And something that's standing out to me is this r squared minus 1. It kind of lends itself for me to figure out whether or not I can multiply everything by something, making all of my denominators, maybe if I'm lucky, go away. Okay? R squared minus 1, that's just going to factor into r plus 1 times r minus 1 because it's called a difference of squares. Now over here, I have not done anything because unfortunately his numerator, well, it can't be factored. And we can only cancel things out that are factors, okay? So now, I'm going to follow the textbook. It says that I'm going to multiply it by my least common denominator here, okay? So my least common denominator to multiply everything by actually is the denominator of r squared minus 1, okay? So I'm going to multiply everything by r squared minus 1, which is really just me saying multiply everything by r plus 1 times r minus 1, because that's what's going to get rid of the most hideous denominator of them all, okay? So, with this little r right here, unfortunately, he gets multiplied still by all the ugliness. R plus 1 and r minus 1. Now, on my other part of the left-hand side, both my denominators will go away, leaving me with just r squared minus 5. Now, on the right-hand side of my equation, my r plus 5 will cancel out, leaving me with the multiplication problem of r squared plus r plus 2 multiplied by r minus 1. Okay? So now I have some multiplication to do in my life. R times r plus 1, that's just r squared plus r. I'm going to multiply that out. Working my way over from the left. And over here, let's just multiply right now. We're going to get r to the third. We're going to have a minus r squared. We're going to have a plus r squared. We're going to have a minus r. We're going to have a plus 2r. And, oh, I've run out of room. And a minus 2. Over here, so I'll do this guy here. We're going to end up with an r to the third minus r squared plus r squared minus r. And we still have this other stuff here, okay? All right, so let's make things a little bit simpler before I move things onto the one side. This is going to cancel each other out, okay? So then we're going to be left with r to the third put it in descending order, plus r squared minus r minus 5, okay? Now, on the other side, we're also going to have these two guys cancel out, and these two will combine. So we're going to be left with r to the third plus r minus 2, okay? So now, hopefully you're a little bit more relieved because I can see the light. I can see that when I subtract r to the third from both sides, guess who goes away? Our cubic term, okay? And so I'm going to get it set equal to 0 because now it's turned into a quadratic. So I'm going to subtract the r from both sides and add 2. So we have r squared minus 2r. Negative 5 plus 2 is negative 3 is equal to 0. One of my favorite methods of solving is by factoring. So we're going to factor. This is going to factor out into two binomials. And so I'm going to ask myself, what multiplies to be negative 3 but adds to be negative 2? So the answer in that case is going to be negative 3 and a positive 1. Oop, turn that into an r. Didn't mean to turn that into an r. All right, so what do we do? Well, we set our factors equal to 0, giving us r is 3 and r is equal to negative 1, okay? So here's where things get tricky. So now we need to plug both of these back into our original, okay? This original equation right here, dun, dun, dun. So, just looking at it really briefly, one of our denominators is r plus 1. If we were to plug in our solution of negative 1 plus 1 is going to equal to 0, which means that we would be having a 0 in the denominator, and that's not okay. Not allowed. So that's why the only solution here, when you go to plug him in, is actually 3. All right, here come the real problems that we actually have in our learning target, the work rate problems, okay? So make sure you read through the question, that way you understand what I'm talking about. I am going to take a different approach to the textbook. I'm going to be using the equation work equals rate times time, okay? And actually what we will specifically be using in this course is work over time equals your rate, okay? So in this question, it talks about the rate of the French and as well as the rate of the English to complete this channel, okay? And it asks how long would it have taken the two of them together to drill this tunnel. So we're essentially going to take the rate of the English, we'll call it ER. We're going to add the rate of the French, and this is going to equal our rate together, okay? Rate of English plus rate of French, that'll beat their together rate, okay? That's why we're going to do the work of the English over the time of the English plus the work of the French over the time of the French, and this will equal the work together over the time together. Now these values will be different. The amount of work. In this scenario, they are building one tunnel together. In the English, well, the English, according to the question, takes 6.2 years. Now, once again, the French, they're building one tunnel, and it takes them 5.8 years together. And together, they're going to build one tunnel, but we don't know how long it's going to take them to build it together, okay? So this is where we need to use our common denominator knowledge here, or simply using these abilities on your graphing calculator, where we're going to add these two fractions together and then just put them in to fractional form. So when you actually add 1 over 6.2 and you add that to 1 over 5.8, you're going to get a hideous decimal if you just type in your calculator, which is really not going to do you any service. But if you type it in, you're going to get 300 over 899, and this will equal 1 over your time. Now, we're really solving here for the time, and notice we have not yet solved for him, so we must cross multiply. So 300t is going to be equal to 899. Okay, once again, still not done. Last thing to do, divide by 300. Okay, so t is going to be equal to whatever 899 is divided by 300, and that's going to get me 2.996666667, okay? That's where the textbook got approximately 3 years together. Logically, it makes sense. Why would it take them longer together than any of the individual? All right, last problem for this section deals with a distance equals rate times time problem, okay? So just like before, I kind of had an equation. Now in the last equation, I decided to get it set equal to my rate. In this scenario, I'm actually going to get it set equal to my time, because if you read the question, what it actually has provided for me is the amount of time it takes in this scenario, okay? That guy right there. So we have distance over rate is also equal to your time. Rate, in this case, that's going to be our speed, and that's something we don't know. That is our variable we don't know, okay? But what we do know is we're going to go against the current as well as with the current, okay? I'm not sure if I drew that correctly. I guess it really depends upon, it depends upon the way you look at it here. And this is going to equal the total amount of time it takes for us to travel up and down, okay? So when we first are going with the current here, okay, the current is just going to help us. It's going to make us travel faster. That's why our rate is going to be r plus 5, okay, because we're going even faster. But regardless, we're going to be traveling those 26 miles, okay. When we're going against the current, it's going to be taking away our speed. That's why we're going to take away the 5 miles per hour. But once again, we're still going to stick to that 26 because that's the total amount of distance, which is in our numerator. Now, the total amount of time it takes is 10 2/3 of an hour, okay? So if you would rather put it back into an improper fraction, personally, I would. I'm going to, in fact. That's going to come out to be 32 over 3, okay? 10 2/3, that's 32 over 3. So now, once again, I'm going to step away from what the textbook did. I'm going to approach it a little bit differently here. Looking at this part of the equation, 26 over r plus 5 plus 26 times r minus 5, I'm going to take this, multiply one of our fractions by one denominator and the other fraction by the other denominator, okay? That way I'm not really changing anything here, and I'm just going to try to get like fractions on one part of my equation. Then I'll turn it into a proportion. So this first guy here becomes 26r, and then we're also dealing with the fact that 26 multiplies by 5. Yes, I know I just gave us really large numbers. It's okay. It's only 130. So then on the denominator, if you notice, that becomes a difference of squares of r squared minus 25. Same thing happens over here, but we're going to end up with 26r plus 130 over r squared minus 25 is equal to 32 1/3. Okay, so let's zoom out once again. Running out of room all over the place. So these can now be combined, and notice when we add negative 130 and add 130 together, they just go away. So we're really just dealing with 26r plus 26r, which just gets me 52r over r squared minus 25. So now I have a proportion. This is where I completely differ from the method of the text. So I'm just going to multiply both sides, cross multiply. Got my proportion here. So I'm going to have 52. I'm going to multiply that by 3. And I'm going to get 156r over here. And then over here I'm going to end up with, oh no, 32 times negative 25. That's what I'm most afraid of, aren't you? I end up with 32r squared, and 32 times negative 25, that just gets me negative 800, okay? So, few bits of words to the wise. It's turned into a quadratic, okay? It's an equation. What I do to one thing, I can also do to another thing. I am noticing that all of these terms actually has a common factor here. Do you see the common factor? I have 156, I have 32, I have 800. What's a number that goes into all three of these numbers? Well, I definitely know 2 does. The question really is, does anything more, does anything bigger go into these? Well, 4, that definitely will help out my cause a little bit. If I divide everything by 4, that'll get me 39r. Then I'm going to do 32, and I'm going to divide him by 4. I'm going to do 800 as well. Get 8r squared, and I'm going to do 800 divided by 4 and get 200. Okay, so I don't think I can go any further down because 39, he is a prime number. So in big quadratics such as this one here, okay, I'm going to recommend you use the quadratic formula. So this is actually where I'm going to send you off. Remember your quadratic formula. If you do not recall your quadratic formula, please look it up on your Quality Core formula sheet, okay? Once you've plugged it into your quadratic formula, I want you to look at your answers in a logical way. Remember, this whole time we've been solving for r. R has represented your rate. When you do the quadratic formula, you end up with a plus or a minus. Should you have a negative rate? Check your answer in the textbook.